For the last 2,500 years, humanity has been debating a really strange question.
And that is?
Whether the chair you're sitting on right now is made of solid, distinct, uncuttable particles.
Or if it's just a collection of vibrating centers of force with no solid core at all.
It is a dizzying thought, isn't it? We assume the world is solid because, well, it feels solid.
But the deeper you look, the stranger it gets.
Here are the most game-changing insights from the essay Practical Wisdom that could transform how you think and act.
And just so you know, you are experiencing a unique two-host AI conversation powered by Google's Notebook LM for deeper, more dynamic analysis.
Today, we're getting into the idea of an element.
And this isn't just a physics lesson. It's really the story of how we, as humans, try to make sense of all the complexity around us.
Always looking for those simple building blocks.
Exactly. Finding the simple parts hidden inside the mess of reality.
So let's define our terms. What exactly is an element in this context? The essay uses some great analogies.
Right. Think of it like this. Letters are the elements of words.
Okay.
And musical tones are the elements of melodies. So physical elements are just the smallest, most fundamental parts that reality can be broken down into.
The bottom layer.
The absolute bottom. But the problem was, nobody could agree on what that bottom layer actually was.
Which led to this huge historical debate in ancient Greece, right? Between two main camps.
Absolutely. On one side, you had what we could call the qualitative view. Think Aristotle.
And they believed elements were defined by their qualities.
Precisely. You have earth, air, fire, and water. Fire is hot and dry. Water is cold and moist. To them, those qualities were the fundamental reality.
And then you have the other team.
The atomists, people like Democritus. And they had a radically different idea. They came up with the word atom.
Which means uncuttable in Greek.
That's it. For them, all of nature was just two things. Bodies and void.
Atoms and empty space.
Yes. But that idea of void, of true emptiness, was incredibly controversial.
Oh, it seems simple enough.
Because for Aristotle's side, nothing can't exist. How can nothing be something? They believed in a plenum, that the universe is completely full, like a bowl of water.
Jam-packed. No gaps anywhere.
Correct. For them, a fish moves by pushing water aside, not by swimming through an empty space. A true void would break their whole model of physics.
It's pretty incredible that they were working all this out just by thinking.
It really is. It highlights the power of pure, rational inquiry. And frankly, that's a skill worth sharpening.
Well, if you want to do just that, you should check out our YouTube channel, Mindful Moments. It offers AI book analysis, summaries, and critiques, all designed to inspire that kind of reflection and rational thought.
It's a great way to keep these kinds of conversations going.
So let's jump forward. We leave the four ancient elements behind, and modern science gives us the periodic table.
And that shift really starts with Antoine Lavoisier. He introduced a new kind of thinking, humility.
How so?
He basically said, an element is just any substance we haven't been able to break down yet.
That's a huge change in mindset. It's not a claim about ultimate truth.
No, it's a statement about the limits of our technology. An element is defined by what we can't do. But then it gets even weirder.
This is where Michael Faraday comes in. And I have to say, this part is mind-bending.
It really is. Most of us, like Isaac Newton, picture atoms as tiny, hard, solid balls.
Like billiard balls, yeah.
Faraday rejected that completely. He saw them as centers of forces.
Okay, wait. Help me with this. This desk feels solid. If it's just centers of force, why doesn't my hand just pass right through it?
Because it's not stuff hitting stuff. It's one force field repelling another.
So like when you push two magnets together and feel that resistance.
Exactly like that. You are not feeling solid matter. You're feeling the repulsion of forces. That solid core, we imagine, is an illusion.
So who is right? Is matter particles or is it forces?
And that's the beautiful point Adler makes in the essay. Science can always find smaller particles. Protons, electrons, quarks.
But it can never actually prove that matter isn't infinitely divisible?
Exactly. You can't run an experiment that involves cutting something forever. So the original philosophical question is still open. We're still asking the same basic questions the Greeks were.
Just with much more sophisticated tools.
And this whole search for elements, it isn't just chemistry. It's the basic structure of how we try to understand anything. We look for the phones in language, the notes in music.
We're always looking for the alphabet of reality.
That's a perfect way to put it.
That is a lot to think about. Click the link on screen for the in-depth book. Subscribe, share, purchase via link, and think rationally.
See the many genre-based book podcasts at Mindful Moments. Nourish your mind on the go.